if you had 0.001 and you needed to use that to multiply, a quick and easy way to look at this, to be, let's say you're multiplying it by 47. Quick and easy way to figure out the number of place values to move the decimal point into 47. How many place values would you move it? So here, 3 and 4. Here's a quick, easy thing. If I have to move that over 3 places to turn it into the number 1, then with that 47, oops, 1, 2, 3, you move it the same number of place values in the opposite direction. So you're making this number larger by 3 place values. So you make this number smaller, and then you still have the same amount. And by turning that into a number that's the number 1, then we have the number 1 multiplied by whatever this would become. So, yeah. To do it again, if you had something like 1,000 multiplied by the 47, if we moved 1, 2, 3 place values to make that a 1, then we've got to move this 3 place values. That keeps everything equal. It's like this balancing act. We make that number bigger by 1,000 times. I'm sorry, we make that number smaller by 1,000 times. We got to make this number bigger by 1,000 times. Same here. Bigger, this one's going to be smaller. So that doesn't really come out of the lesson, but it's in there. It's not real clear. So, these were your problems, right? Okay. Do you want to ask about any of them? 20? Yeah, there are a lot of questions while we were working on it, but. Anything else other than 20? I'm sorry? 21.
And 26.
26?
Yes.
Anything else?
C.
12C? It's really hard to hear. You have to be louder. So let's see. 1 quintillionth as a power of 10. Oh my gosh. So that's 1, isn't it? That's 1,000, million. What's this? Billion,
Trillion.
trillion,
Quadrillion.
quadrillion,
Quintillion.
quintillion.
18.
So how many place values would you have to move to get it to turn into the number 1? 18. 3, 6, 9, 12, 15, 18 places. That's 10 to the 18th. 10 to the 19th would be 1 too far. Yeah, I don't know when you're going to use that.
Which one is that for?
That's question 12C. So question 20. In the metric system, all the prefixes have consistent meanings. Kilo is 1,000, centi is 100th. Yeah?
It says quintillion, so it would be a decimal.
Oh,
There's a TH.
oops. It's quintillion. Okay, my bad. Let's stop. Let's back up. Find I want my room back. Here we go. Okay, so this would be quintillion, but the quintillion would be 1 over that, right?
And it says to do it as a power of 10, not as a whole, right?
Well, this is a power of 10. I
Yeah.
just did quintillion, my mistake, my bad. So quintillion would be 10 to the negative 18. Remember over on this side of the board yesterday, I wrote some things, I had like 10 to the 6 was a million. And then down here, I had 10 to the negative 6, which was a million. And then I also had 10 to the third, and for that one I wrote 1,000. And then there was, 10 to the second, the first, the 0, the negative first, the negative second, and 10 to the negative third, which is 1,000. And I showed how there's symmetry between these in the naming and in the exponent. So if you went and continued 10 to the 7th and 8th and 9th and so on until you got to 10 to the 18th, and that was quintillion, then quintillion would be 10 to the negative 18th. So that's not the most important thing in the lesson. So if it's a little fuzzy, that won't mean the difference between graduating from high school and not. You'll be okay. That's a pretty picky question. But the next one, 20. If kilo is 1,000, excuse me, centi is 100th, milli is 1,000th. Explain the meaning of kilogram, centimeter, and milliliter. So what does kilo mean? Yeah? 1,000. So then if you just substituted the number 1,000 and then said 1,000 grams, that would be the same as a kilogram. And then what is the next one? It was meter? Like this? Oops, yeah, I. So then centi is 1/100th. So you could just read this 1/100th of a meter. Because if you have a centimeter, that's only 1/100th of the entire meter. And then it's milliliter. So milli is, yeah. So that's 1,000th of a liter. What's it?
Millimeter.
Oh, it's millimeter? Oh, it'll be the same thing then. I thought one of them was liter. This is still gonna be 1,000th of a meter. Or you could have a milligram, which would be 1,000th of a gram. You learn that stuff with Mr. Baumgartner when you do the metric system?
Yeah.
Does he teach it a little bit that way?
Looks like.
Probably, some of you are nodding your heads, maybe, yeah. 21. Oh, sunburn is primarily caused by ultraviolet light rays with wavelengths between 290 billionths and 400 billionths of a meter. Write these in decimal form. 290 and 400. So you know that light travels in waves?
Yes.
Yeah. So wavelength is from here to here. So UV light goes from this to this range of length. So like if you did a rainbow of colors, what's the rainbow? What are the names of the colors?
Red. I don't know colors.
Yeah, actually the new ones, the new way of looking at this, they say that indigo doesn't really exist. I don't really know why they say that, but I remember reading an article that they say now blue and violet are considered to be the same. There's no such thing as indigo. Which maybe that's like saying Pluto's not a planet, but anyway, that's usually what you learn and see. So where is ultraviolet? Is it out here? Or is it out here?
Is it what?
Where are ultraviolet waves?
To the
Yeah,
right.
because they're ultra, they're beyond violet. So this is what you get to see. And then UV light is just beyond.
Is there ultra red?
There's not ultra red, but there's infrared. And if you stand in front of a wood stove, or you feel the warmth coming off of an oven, those are infrared waves. And these are longer, and these are shorter. And if you keep going out here, you have things like X-rays and gamma rays. So the short little ones those are the dangerous ones. These are not thought to be so dangerous.
Which one is the sun on?
The sun gives off everything.
Oh, okay.
Yeah, they give off all of this stuff and beyond. Things that we don't, they give off, these are all waves, but the sun gives off little particles too that go shooting through space. So anyway, size. We gotta write that as a decimal, is that right?
Yeah.
So if we do this, if we start naming our place values, this is the digit that needs to go into this place value. So, what is this? Tenths,
Hundred,
hundredths,
thousands,
10,000s, tenths, hundreds, thousands, 10,000s, hundreds, millions, 10 millions, 100 millions, billions. So now come in and put your 290 in there so that that zero is this zero. So we gotta back off.
360. Here.
There's another way to do it. And this might be easier. If I wrote a fraction with 290 on the top over a billion, but then I lined up my place values, so what I'm doing is I'm writing 290 billionths as a fraction. Okay, here's where the decimal point is in each of these numbers. And you know that with equivalent fractions, you can multiply the top and the bottom by the same number and they're still equal fractions. You can also divide the top and the bottom by the same numbers, and you have equal fractions. So what we're going to do is we're going to divide this one by 10 9 times to make this the location of the decimal point. And I'll do the same thing up on top. 1, 2, 3. So now I've divided the top by 10 the same number of times. And then I'll put a 0 in front of it. So now that's this value, the decimal point's no longer at the end, over 1. And any number over 1 is just the numerator. So you can ignore the denominator, there's your decimal number. In another way, that's for in the 100 billions place value. Is that right? No, no, don't. Replay, back up. No, we don't want to do that. Do one of these two things here. Either call this the billionths place value like I did here, or write 400 over 1 billion, and then put enough places to hold all of these place values. So your decimal point here, your decimal point there. The numerator is what your answer would be. Okay, any other questions? That's 21. Yes.
26.
Oh, that's right, 26. I didn't write it down. Oh, you may have heard of megabytes, gigabytes, and terabytes, yeah?
Yes.
Sure. You may also have heard of microseconds. You ever hear that?
Yes.
Or nanoseconds?
Yep.
Yeah, nano is a relatively new thing because it's so tiny. It's been hard to measure for a long time. And then pico. Ooh. Look up what the prefixes mega, giga, tera, micro, nano, and pico mean. Did anybody get it done?
Yeah.
Yeah.
So what's mega?
10 to the 6th.
10 to the 6th, that's a million? So a megabyte is a million bytes,
Yeah.
which used to be a lot, but it's not anymore. It probably still is. What's a byte? What's 1 byte?
Isn't there like something smaller than bytes, like
It's like 1 digit, like a 0 or a 1. That's a byte.
A 0 or a 1?
Yeah,
You're going to have to do one or the other, because 0 is not a 1, it's fine.
exactly. So it's either turned off or it's turned on. That's how all this stuff works. So it's either off or it's on. If it's a 0, it's off. If it's 1, it's on, I think. Might be the other way around, I'm not sure.
How would it be the other way around?
Just because that's the way it is, I'm not sure.
Okay.
But it's either on or it's off. So if you have a million locations that can be either on or off, then you have a megabyte. So what's the next one they have? Giga? What is giga? 10 to the 9th, which is billion. So a gigabyte is a billion bytes of information. A billion ons and offs. What's a tera? 10 to the 12th. So a tera is like a billion, well, a tera would be like a million. So if you had a tera, that would be like having 10 to the 6th multiplied by 10 to the 6th. So that's like a million times a million. That's a tera.
But what is like actual, like for like numbers?
Numbers, it's like this.
No. Yeah, like what would a million times a million be?
A million times a million would be a trillion. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right there. That's a trillion. So a terabyte is a trillion bytes. And then what do we have? Micro. So that's on the other side. That's a fraction, isn't it? What's a micro? 10 to the negative 6. Which is 1 millionth. So it's like this. 1/1,000,000. So like a microgram, when they measure vitamins and minerals in food, and they say how many micrograms there are, they're talking about millionths of a gram. And a gram is what a pencil eraser is for mass. 20 drops of water is 1 gram. So a millionth of that is very little. Then what is there? What's next? Nano. What's a nano?
It's like a nanosecond. So,
-9th? So that's 1/1000,000th. So that's really small. And then what's pico? 10 to the -12. That's 1/1,000,000,000th. So, I don't know, things that they measure using pico.
Kilogram?
I'm not even sure what they use to measure pico. Like, studying at the nano size is kind of new science, even.
what about pico?
Yeah, I don't know what they do with picos. I don't know what they measure.
Huge.
Yeah. Okay, so,
For 20?
yeah.
What if you just said 1,000 kilogram?
Yeah, so kilogram, you just say 1,000 grams. Per centimeter, you just say 100th of a meter. Yeah. So we use these prefixes instead of saying, you know, like, how many micrograms is this? Well, instead of saying how many millionths of a gram, they use micro. Or instead of, you know, picking up, you know, something like the distance being 2,000 kilometers, that's easier than saying 2,000 meters. So we use kilo as a number in words. Okay, so I have a quiz for you. You may use your notes, you may use your homework.
Quiz? Can we use our calculators?
Yeah, I think you can. You've been using them, right?
Yeah.
I
As
don't know
long
if
as
it's
we
gonna be helpful.
understand the question, that we're just using the calculators to get the answers.
Yeah.
Yeah, but I don't think that there's anything in here that a calculator's really gonna help you with. But you're welcome to use it if you wish. Yeah, it's kind of cramped space, but I think you'll be okay. If you don't like the amount of space, you're welcome to work on the other side. Just make sure you number everything. But I think for this one, there'll be enough. I think there'll be enough space. If you don't understand a question, please ask. We can try to help reword it for you. These quizzes, the questions are written differently than what you're used to in the last couple of years. So,
Wait, how many points are quizzes again?
what's that?
How many points are quizzes?
This one is set up that every question is worth 2 points, and there's a total of 18 points. And if you took a full-blown chapter test, that'll be a total of 100 points. So this is just like a fifth of a chapter test, or a little bit less.
It is, no, it's 50 is less. 50 is less than 20.
Okay, Ryan. We're taking these ones to yourself.
Okay.
You can let work.
Maybe you can use your notes.
What's the date?
Today's the 10th. Did I give one to everybody?
No.
No, I walked right by YouTube, didn't I? I'm sorry.
Yeah.
How can I do this? Again, you can use any of your notes, any of your homework, but not each other. Sorry about that. Writing a fraction.
So, instead of one, the definition of fractional is like a number that becomes a fraction, right? So it says show us six, the 639 is irrational by writing, or is rational by writing it as a ratio of two integers.
So if you write it as a fraction,
Yeah.
you have two integers, you have a numerator and a denominator.
Wait, a ratio can, you can,
Yeah, a ratio can be written, a
That's
fraction is a
right.
ratio.
yeah,
Yeah, so you're just writing that first one as a fraction.
okay.
Then you're just using an integer for the numerator and for the denominator. And you'll be good.